Good morning. It's morning in California and in New Mexico and other places in between. All right. Last night I was preparing for this class today, and how do you think I, in part, prepared for today?
Did all the
Okay, what I did is I watched a video. Like if you see that QR code that's on that upper right corner of that sheet that you have, that is a QR code for a video that shows how to work these problems out. So it kind of helps me get my mind back in sync about this. But what do you think a problem was that I had looking at that prior video lesson reenacting these odd number problems worked out? What kind of problem do you think I had?
You messed up.
No, I didn't mess up this time. That's a good guess, because that's a likely occurrence. Okay. Any guesses? What I did? Why I had a little bit of problem for today? Well, I will tell you. What it is that on that prior video, do you think I was working from this kind of calculator that you now hold in your hand? No, it was a TI Inspire calculator. So the TI Inspire will do these types of reciprocal ratios that you actually have to do a little bit more figuring on with the calculators you have now. And none, probably a better example than problem number 25, which is a secant. What is the secant?
The reciprocal of the cosine.
Who said that? Reciprocal of cosine, right here, and it's right here on your ACP formula chart. How many of you actually got this from memory? How many of you know it from memory? You know it from memory? You do? Good. So this is one that I'd like you to have from memory, but failing memory, what do you have? You have your chart that's available to you, right? So Emily said it. You said it right. Did you say it without? You remembered it, right? Okay, good. So some of you remember that. And if you don't remember everything all at once in this class, am I terribly upset about that? Not yet. Not yet. Okay, so how are we going to rewrite this thing? And if you look at our button in our calculator, what do we have on the button for our calculator? What do we have on the buttons in our calculator? We have sine, cosine, and tangent, right? And we don't have a secant button on this calculator, but since we have a cosine button, we can do this, right? Okay, in order to get this right, what do we have to be sure of on our calculator? Let's look back at our calculator. We have to make sure our calculator is in degrees. If it's not, and I'll tell you that in this class, this second semester, you might find yourself switching back and forth between degrees and radians. My way of looking at it is I like to just probably keep the thing in degrees and then work from there. I will tell you that fifth period, they change this back into radians depending on the situation, and that's very easy to do. So it's just really kind of up to you, right? As you use your own mathematician sense. So right now I know that I'm in degrees, and if I'm not in degrees, I know I can go down here and change it by mode, right? So we're in degrees, so I'm going to put 1 over cosine, was it 45 degrees? And this should be our answer, 1.414. Now, one thing it says, give an exact answer. Does this thing here look like an exact answer? No, it doesn't. Okay, so this is one that you could conceivably do without a calculator. And so when you have 30-degree angles, what are the ones that we talked about last week? We talked about 0, 30, 45, 60, 90, right? those are all ones that you can do without a calculator, conceivably, even though they gave you instructions to do with a calculator. Are those conflicting instructions?
Yes.
Yeah, they are. Are you terribly confused by them? No, I'm not either. I'm not too worried about them. But I want to explain how this is the case. What happens is cosine of 45 degrees equals square root of 2 over 2. And how do I remember that? The x's are 1 square root of 3 over 2 horizontal. They must be square root of 2 over 2, right? And next are 1, half, and zeros. So square root of 2 over 2. So I know that my secant theta is going to be what? Equals 2 over square root of 2. If you put that in the calculator, and this 2 over square root of 2, that's actually an exact answer, whereas this one here is not. Okay?
So whenever.
So we'll kind of talk our way through these 25 through 28, because this is sort of an oddity that the book is asking you to do something that doesn't 100% make sense. So don't be worried about it. Try to learn from it, right? Okay, I'm going to call on somebody for 26 here. And this time we're going to have the pleasure to call on Will, maybe. But let's go here. And is this one here you can remember from the song? 0, 1 half and square root of 2 over 2 is pi over 3. Let's see, square root of 3 over 2 and 1. So this is what? 3 over 2, right? So I'm going to call on somebody. It's going to be Will. You got this one, Will? All right, Will, what do you got? 0.866. But again, is this an exact answer?
No.
No, so let's work on the exact answer. I think Will missed some of this. Okay, here it is. 0, 1 half and square root of 2 over 2. That's what I'm telling you. Square root of 3 over 2 and 1. So what's this going to be? 0, 1 half and square root of 2 over 2. That's what I'm telling you. Square root of 3 over 2 and 1. Which one is that? Square root of 3 over 2, right? So this is going to be actually square root of 3 over 2, which is the sine is the height at any radian. The square root of 4 over 2 is 1. And did you get the lyrics? I sent you the lyrics. I gave you those.
Yeah,
you have lyrics? Okay, good. So square root of 3 over 2. Square root of 3 over 2. So exact answer is square root of 3 over 2. That's an exact answer. Okay. Next, I'm going to call on somebody. We have cosecant of pi over 3. Is that going to be an angle measure in degrees or in radians? Radians, good job. Okay, here we go. Emma, or Hannah, it's Emma. All right, Emma. All right, Emma?
You have both answers, Richard?
Well,
Like the,
oh, you mean the exact answer and the decimalized answer? Whatever you can give me. What can you give me?
well, I got the 1 over sine and then the pi over 3.
Okay.
And when I got that, I got 1.15. And when we found the fraction, it was 2 over the square root of 3.
Okay, which equals 2 over square root of 3. Let's talk about that. And so your exact answer is 2 over square root of 3?
Yes.
I think that's it. Okay, this comes back, secant is related to which ratio?
Sine.
Sine, right? So here we are, like problem 26 was square root of 3 over 2, right? Sine, 60 degrees. And now we're talking about cosecant of the same angle, right? So that's just going to be square root of 3 over 2 turned upside down, just like this. So yes, this is your exact answer, and this is your calculator estimation answer. Okay, that's good work. How did you figure it out, Emma? Just from your knowledge of unit circle trigonometry?
A little help.
A little help?
Okay.
Who's been helping you?
And
Katie, who's helping me? Yeah, well, I give you credit for that. Good help. So Katie, are you like a unit circle trigonometry expert? Really?
no, I just understand.
Okay, you understand some?
Just for right now. I don't know about later.
Yeah, that's right. Well, sometimes we just take what we can get, right? We have our moment, we take what we can get. Okay, I'm going to go ahead and spin somebody for 28. And 28. 28 is going to be Hannah. So Hannah, give me a minute. So Hannah, you're on deck. Okay, Hannah.
Degrees is square root of 3 over 2. No, wait, so that's square root of 2. It's just a reciprocal of the yes.
All right, Hannah, what do you think?
I got 1.732 as,
1.732, okay.
but I don't know how to find the other answer. I don't understand that.
Yeah, this is going to be it. That's going to be it. Let me tell you what it is. One thing I haven't told you about yet, and I've told you the hand, right? So I'm going to now kind of preliminarily introduce to you called the hand trick for sine and cosine and tangent. Okay, so this is your left hand that you look at. You know what these angles are from the song, right? And here we have pi over 3, so we know it's this one, right? Okay, now tangent, there's a tangent identity, which is the tangent is sine over cosine. Okay, and so how do you find sine here, using the hand trick, is square root of fingers, over 2. So our sine is going to be square root of 3 over 2. That's our sine. And our cosine is going to be square root of this finger, which is the thumb, but square root of this over 2. What's square root of 1? 1 over 2. So our cosine is 1 over 2. Our sine is square root of 3 over 2. So our tangent is going to be square root of 3 over square root of 1. So what is square root of 3 over square root of 1? It's just square root of 3. So punch square root of 3 in your calculator, you're going to get that.
I'm so confused.
We're going to do hand trick more. You're confused by this business here
Yes.
with the hand?
Yeah.
Okay, we're going to do this more. I'm going to show it, and it's It really saves you from having to look at a unit circle chart, which I'm going to hand out at that point. But so that's it, isn't it? Square root of 3 is our tangent. Okay, good work. Now, the next ones here are a little more straightforward calculator one, where this actually is a good, well-constructed answer here. So just enter these in your calculator. I'll choose somebody. Like on this one here, I would change back to degrees, definitely. And it's just an exercise of entering this in your calculators. Okay, let's go ahead and spin this one. Be Kaylee. All right, Kaylee, it's you. Okay. What'd you get? That's the nearest 3 decimal places. Is that right? Okay, yes, that is right. And can we get an exact answer on this? We might be able to, but if you don't see like a 30, 60, or 90, or 45, you're not expected to know what those are beyond special right triangles, either in this class or in calculus. So if you see, if you're looking for an exact answer, and it's not one of those standard 30, 60, 90, or related 45, related to those, you're not expected to know an exact answer for it. So really, an answer, the best you can do is a calculator. Decimal approximation. Yeah, thanks. You got a QR code. Okay, you missed it. Okay. Let's go on to the next one. Oh, I don't even have to erase this, do I? Actually, I'm going to save it. So I have the bigger version of, okay, tangent. Tangent of 8 degrees. All right, Carmen, it's you. What do you got, Carmen? 0.141? Yeah, I think that's it. So tangent 8 degrees. 0.141, that's rounded to the third 3 decimal places, right? So that is our answer. Okay, next we have, the next 2 problems are in, what kind of mode did we call this? Because it's been a little while since we've gone over this, right? Right at the beginning of the semester we did one like this. What mode did we call this? Might have been the first day.
Depeche mode.
Depeche mode? No. I got a story about Depeche mode. We'll have to turn off the camera first. It's not that bad, but it'll get you thinking about it. Okay. Did anybody remember how to do this?
No.
You know?
I remember. I kind of remember like the 60 and 180, but that's it.
Yeah, so what it is, you got to convert this into degrees. So this is going to be equal to cosine of 19 plus, we got to convert this into degrees, so 23 over 60. So if we just put it in like this, we'll get it. So in your calculator, we got cosine 19 plus 23 over 60. And so that's going to give us 0.9433, right?
Where'd you get the 60 from?
What happens is-
Each one of those is a 60th of a
Yeah, what Will said.
I'm sorry.
Because if we take 23 minutes, we want to convert it into degrees, we do that by multiplying by 1 degree over 60 minutes.
Seconds has to,
So minutes over minutes cancel. So we have 23/60ths of a degree. So that's where that comes from. It's been a while. If you look back at the papers I've handed out to you, it's in there someplace. Does that seem like a long time ago?
yes.
So who is our answerer on this one? On the last one?
I answered the question about the minutes, not the.
On the other one? But who answered number 30?
That was
Hey.
Haley.
Oh, I would give you a sticker over here. All right, good. I want to keep up with my stickers. I want to keep up with my stickers. All right. Okay, what I want to do now is call on somebody for 32. 32 is a similar type of problem to 31 in that respect. So we're going to have one of our 3 remaining victims here. It'll be Angel, okay. Okay, Angel. What do we got here?
1438.
0.438?
What do you have?
439.
0.439?
439.
Which you got, I hope, by going tangent, was it 23 plus 42/60ths? Is that how you did it, Angel?
Yeah.
Yeah, that should be it. Okay. Questions on that one? On those? Pretty simple.
We're doing the back.
Yeah, we'll do that. Okay, so, actually, I think on 5th period, we got to just almost to number 40. Not quite. So we should get to all these today, I hope. Okay, 33. Now you have a choice to make here, don't you? How would you do a problem like 33 and 34? What's one way you could solve this?
I just like
What was your calculator set in? Radians, right? So if your calculator set in radians, you can just plug it in like this, right? If you want to keep your calculator in degrees, what can you do? Well, I'll show you after I pick somebody.
Richard G, I sent you a calculator for the day.
Oh, did you? You got to the right time? Kayla, this is you. All right, Kayla, what'd you get for this one?
Huh?
33.
.268.
Okay, so did you change it into radians? Is that how you did it? Okay, if you don't change it to radians, what you can do is you can take this pi over 12, you can convert that to radians by multiplying by 180 over pi. So what it is, we get 15 degrees. So if you have your calculator in degrees, you say tangent 15 degrees, I'm in degrees, right? So tangent 15 degrees, way of checking Kayla's work. 0.268, is that what you got for it? Yep, that's it. Okay? All right, does that make halfway a little bit of sense?
went up to the restroom, but she gave me her paper to give you the answer. to.
Okay, what is our answer for that?
She got .208.
Right, which is gonna be, that's gonna be 12 degrees, right? Let's see, sine 12 degrees. .208, right? Okay, that's right. Okay, good. Let's go look at 35, and I'm going to reset the wheel, the name choosing wheel for this. Okay, so now I go to open 6th period. It's going to be Angel or Kaylee. It's Kaylee, all right. All right, Kaylee, you got 35? 1.524. How'd you do that one?
1 over
Cosine 49 degrees. Okay, yeah, that's it. Okay. I think I might have told you this, but in your absolute value of secant and cosecant has to be greater than or equal to your absolute value of cosecant or secant has to be greater than or equal to
1.
greater than or equal to 1. And the absolute value of cosine or sine has to be less than or equal to 1. All right. Okay, next, 36. Okay, another one for him. All right, 3.071. And you should, for this, you got, it's going to be 1 over sine of 49 degrees, is that right? Is that how you did it?
Over 19.
Over 19.
Well, 19, I put 49, should be 19, thank you. Can't even read my own typing. I was going to say read my own writing. Okay, questions on that? Good, good, good. Okay. Let's get these last ones here. Now, if you get a number like this without a symbol, can you tell from that number itself if you're talking about degrees or radians? Yeah, if you see a number like this, by itself like this without a degree symbol, you have to make an assumption. The assumption I would make, especially for a number like that, a small number like less than 1, is that's radians. So the intention of the textbook writer is for that to be radians. Okay, let's go to Kenzie. Kenzie didn't make it. I didn't get her off the list here. Okay, it's gonna be Angel. All right, Angel. What do you think?
Sixty-four point three seven seven.
64.372.
372.
I don't think it should be that.
How do you do this? What are you remoting?
Yes, you might want to change yours into radians for that. That, or you can take that .89 and convert it to degrees by multiplying by 180 over pi. You can do it that way. So if you do that way, you can keep your calculator in degrees and do it that way. So what'd you get for your answer? 0.809. Did you convert your calculator to radians? Is that how you did it?
Yeah.
Yeah. That might be the easiest way to do this one. I agree. Okay, next one we got is, what I'll do. Good, we have just enough time to finish everything here. That's good.
So we'll be,
Okay. 3.079, that sounds familiar. 3.079, okay, that's going to be good. I'm just going to go on these last ones here. You already got chosen. No. Okay, Carmen, you got this one? $3.414? Is that right? Everybody get that? Okay, and then the last one. So, Hannah and Carmen. This one will be Will. All right, Will, what'd you get? 236. Okay, good.
Do you want our factoring many, please?
What?
Factoring many, please?
Or when you're finished with it, yeah. If you're finished.